Hi. In this video, we are going to continue our section on triangle geometry. In last class, we saw a few results on the five triangle centers. And in this class, we'll look at some problems based on those that theory. So we'll start off with this question. ABCD is a parallelogram where G is the centroid of triangle ABD and P and Q lie on the line BT such that GP is perpendicular to PC and GQ is perpendicular to QC. So I'll draw the figure and we'll try to understand what this means. So this is a parallelogram ABCD and we make the diagonals BD, extend it a little bit on both sides, and AC. Okay. And G is the centroid of triangle ABD. Triangle ABD centroid. Let's say G is somewhere here. You should realize that AC and BD are diagonals of a parallelogram. So they will bisect each other at this point. And if we call this M is the midpoint of BD and also the midpoint of AC, right? So that means AM is a median of triangle ABD. Therefore, the centroid G will lie on the median. Centroid of triangle ABD will lie on the median, and we can say that it will be somewhere here. 2:1 ratio, right? Somewhere here. So this is my G, and now we have to make lines from here. P and Q lie on the line BD such that GP is perpendicular to PC. So let's say P is somewhere here. P is here, let's say. So we know that GP is perpendicular to PC. So this angle is apparently 90 degree. And similarly, GQ, Q will be somewhere here, let's say, is perpendicular to QC. So this angle is also 90 degree. This angle is also 90 degree. We have made 2 points P. I should rub off this part here. So we have made 2 points P. This is D. P on BD and also Q on BD such that GQ is perpendicular to QC and GP is perpendicular to PC. And we have to show that AG is the bisector of angle PAQ. PAQ. So if we roughly join it like this, AG should be, we have to show that AG is the bisector of PAQ angle, right? Okay. The figure is obviously not accurate because I'm drawing by hand. You should try and draw a better figure using a compass and ruler. What we will say here, you know that M is intersection of AC intersection BD, right? So M is midpoint of ABD. We already said M lies on median of triangle ABD, and therefore G lies on AC because G was a centroid of the triangle ABD, right? So now that we know that angle GPC is equal to angle GQC, GPC and GQC are both 90 degree. So we can say that PGQC, the quadrilateral PGQC is cyclic, right? And therefore, if PGQC quadrilateral is cyclic, then that implies that GC is the diameter. GC is the diameter of the circle. Which circle? The circle circumscribing PGQC, right? So if GC is the diameter of that circle, the center of that circle would be the midpoint of GC. So let's label it as O here, and O is midpoint of GC, right? So O is midpoint of GC and is the center of the circle. Now, by power of point M, we can say that M is a chord running through the circle circumscribing PGQC, right? So we can say PM into MQ should be equal to GM into MC. This is by power of a point M. This is the first result that we will use. Now we also know that AG is to GM should be 2:1, 2:1, and GM is to MC. We have to find that out. So we know that AM is equal to MC because M was the midpoint of AC. So if you take AM, if you take AG as 2K and GM as K, the length of these segments, AM is equal to 3K. Therefore, MC is also equal to 3K. So we get AG is to GM is to MC is the ratio of 2:1:3, right? AG is to GM is to MC is the ratio 2:1:3. And now OC is equal to half of GC, and GC would be GM plus MC. GC is GM plus MC, GM plus MC, and GM was K and MC was 3K. So GM plus MC is 4K. So half of 4K will be 2K. So OC is equal to 2K, right? So that means OC length is equal to AG length, right? Because AG was also 2K. Now OC is also coming as 2K, right? So OC is equal to AG. So now you realize that this O point and the G point, O and G are symmetric with respect to M, with respect to point M. O and G are symmetric with respect to point M because I can now replace, I will just do it here. I can say GM into MC, right? GM into MC is equal to, instead of GM is length is K, and we can say OM is also K, right? GM into MC is OM into AM. Why? Why are we saying this? Because GM is equal to OM and MC is equal to AM. MC is 2K, AM is 2K. So we can replace the length, right? And similarly, GM is 1K because AG is to GM is 2:1 ratio. So similarly, OM is also 1K, right? Because we know OC is 2K. OC is 2K and OM is 1K. Basically, the whole length AM and MC were equal. So they were being bisected, and G and O are symmetric points. So we can write this GM into MC is OM into AM. And we already had GM into MC is equal to PM into MQ from 1 here. So we get PM into MQ is equal to OM into MK. PM into MQ is equal to OM into AM, right? This is what we are getting now, new result, right? Now this implies that APOQ are concyclic points. Think about it, OM into AM, and PM into MQ. So that is like power of a point through the circle circumscribing APOQ, right? The power of a point M is same. If there was a circle circumscribing APOQ, then this is the result we would have gotten. So by power of a point theorem, we can say APOQ is cyclic, right? And since we know that OP is equal to OQ. Why is OP equal to OQ? Because O is the center of the circle. O is center. And P and Q are points. O is center of which circle? O is center of PGQC, right? O was the center of the PGQC cyclic quadrilateral earlier. So OP was equal to OQ, right? And now we also get that from here we can say OP is equal to OQ and OQ is equal to half of GC, right? Because GC was the diameter of the PGQC circle, right? So OP and OQ are what? OP and OQ are radiuses of the PGQC circle and half of the GC would be same. So we have OP is equal to OQ is equal to half of a GC, this result, and we have APOQ are cyclic concyclic points. So if I redraw the figure a little bit, I will just do it here. I will try to make the APOQ cyclic quadrilateral. So I will have P here, A here, O somewhere here, and Q here. This is my quadrilateral APOQ, let's say, and we already know OP and OQ are same, right? Because they were the radius of the circumcircle of PGQC, right? And we know that this is a cyclic quadrilateral. So the angle here, this angle should be equal to this angle because they have the same chord. If you make a circle circumscribing them, the chord lengths are same. The chord PO is same as chord OQ. So the angle that they subtend here should be same. So angle PAO should be equal to QAO, right? So if angle PAO is equal to QAO, that just proves that this angle PAO is equal to this angle, and that just shows that AG is the angle bisector of angle PAQ, right? So we are easily getting AG is angle bisector of PAQ because we proved that APOQ are concyclic. And how did we get that? We got that because we first got that PGQC is concyclic, and then we looked at these power of a point relations, right? We had to use the centroid properties also to figure this out. We have to realize that G and O are symmetric about the line BD, right? So hopefully you've understood the problem. If you haven't, please go back to the video, try it yourself a little bit, and then you can get the logic of each step, right? Let's move on to the next question. This question says, in a triangle ABC, assume that AB is equal to AC. I is the incenter. I is the incenter. D is a point inside triangle ABC such that IBCD are concyclic. Let E be a point on line AD such that CE is parallel to BD. We have to show that CD square is equal to BD into CE. We have to prove this result. CD square is equal to BD into CE. And we will say, we'll first draw the figure. It's an isosceles triangle. A, B, C. It's an isosceles triangle. My incenter will be somewhere here. Incenter is I is here. And D is a point inside such that I, B, C, D are concyclic. So I, B, C, D are concyclic. So let's try and draw the circle through this. So and let's label D as a point here somewhere, right? I will just remove this circle now. So we have I here, D here, C here, and B here.